Okay, now that we know how to find the mean, we're going to talk about how we can use the mean to summarize and to compare data. So what I want you to do is I want you to open your workbook to page 329. We're going to skip the top part. We're going to go right to number 4. One way to compare two sets of data is to compare the mean of one set to the mean of the other set. So number 4 says the number of points that two basketball players scored is shown in the table at the right. One player missed the first 2 games of the season, so that looks like player B missed the first 2 games, and you can see that because we've got these blanks here. Which player made a greater contribution of points to the team on a game-by-game basis? Give a reason to support your answer. So just by looking at all these numbers, can you tell which player made a greater contribution, which player really helped their team get more points? It's kind of hard to tell, especially with player B not having as many, points listed as player A. You might think player A would be the better one because they were there every game. Looks like they scored points at every game. But I don't know, player B also has, it looks like they have the 11, the 10. They also have, a greater number of, I guess maybe not, but they do have a lot of bigger numbers there. So let's find out. Let's find the average. Let's find the mean for each player. So if I start with player A, I'm going to add them all up. 5 plus 8 plus 1 plus 12 plus 9 plus 4 plus 10 plus 7. If you add up all of those data values, all of those points scored, you should get 56. And since we have 8 sets of numbers there, 8 values, we can divide by 8. 56 divided by 8, that's going to give me 7. So it looks like player A scored an average of 7 points per game. Now let's take a look at player B. So I'm going to add up 11 plus 7 plus 6 plus 6 plus 8 plus 10. And when I add them up, I get 48. So just by looking at this, you're probably thinking, okay, player A definitely scored more points than player B, so player A must have made more of a contribution to the team. Well, what if we divide by, let's see, we have 6 numbers this time because player B only participated in 6 games, and 48 divided by 6 is 8. So if you look at it this way, player A scored an average of 7 points per game, player B scored an average of 8 points per game. So if you're looking at a game-by-game basis, even though player A technically scored more points overall, player B scored more points per game. So I'm going to say player B made a greater contribution. On a game-by-game basis because their mean points per game was greater than player A. Okay. Now let's move on to the next page, workbook page 330. This is where it gets a little more challenging. In number 5 it says, in Miss Dixon's science class, the mean of 4 quiz scores and a final test score determine the quarterly grade. During the first quarter, Yunni's 4 quiz scores were 95, 99, 86, and 94. Okay, so we've got 4 quiz grades so far, and it looks like there's still a final test that Yunni hasn't taken yet. But what is the sum of Yunni's 4 quiz scores? So far, if you were to add them all up, if you add up, your 95 plus your 99 plus your 86 plus your 84, what is the sum so far? Well, so far it looks like, and that adds up to 374. So far, it looks like Yunni's got like 374 points. That's her sum of her 4 quizzes. Now, what must the sum of Yunni's 5 scores be so that she gets an average of 90 or more on all 4 quizzes and the test? Don't forget she hasn't taken the test yet. So this is just the 4 quizzes. There's still another test that she needs to take to get her total quarterly grade. So what we have to do is we have to think to ourselves, we have to make sure that we get an average of 90. Well, remember, you have to take a sum of all your scores and divide it by the number of data values. And it looks like we're trying to get 90. So we have to think to ourselves, what number divided by the number of data values equals 90? Well, how many data values are we talking here? We're talking about 5. The reason we're talking about 5 is because we've got 4 quiz scores, and then there's still a test that hasn't been taken yet. So the sum of all of our numbers divided by 5 equals 90. So now we have to work backwards. What number divided by 5 is going to equal 90? Hopefully you recognize that you can do the inverse operation here. 90 times 5 would give you 450. So 450, let's change the color here. 450 is the sum of all of the scores that Yunni needs to get in order to get an average of 90. Okay? Let's see, 450, because 450 divided by 5 gives us our average of 90. So now we have to think to ourselves, what is the minimum score that Yunni must earn on the final test to have an average score of at least 90 for the quarter? Explain. So remember, she's got these 4 quiz scores so far. She's got 95, she's got 99, she's got 86, and she's got, oops, I just realized that was supposed to be 94. My mistake. So 95, 99, 86, 94. When you add them up right now, we have 374. So she's got 374. What I need to do is figure out how much more she needs to get 450. So I'm going to take the 450, which is our goal, or Yunni's goal, and I'm going to subtract out the 374 that she has so far, and that's going to be 76. So that means that Yunni must get at least a 76 on this next test in order to still get an average of 90. That is the minimum. So 76, because an average score of 90 requires 450 points if Yunni has 374 points, 76 more points are needed to reach, running out of space here, 450. So that's how you can work this out. You have to be able to work backwards. You have to think, hey, well, if I want this to be my average, what number must I divide by the number of data values to get that? And then you can figure out, what missing numbers you need to make that happen. Let's do another one. Let's look at number 6. The average age in years of the 4 people in Jorge's family is 25. So the average is 25. The mean is 25. Jorge is 12 years old. His mom is 38 years old. And his dad is 41 years old. So how old is Jorge's sister? So we're talking about 4 data values here. We've got 12, which is Jorge's age. We've got 38, which is his mom's age. We've got 41, which is his dad's age. But what we're missing is the sister's age. Well, remember, we are telling you that the average age, the mean age, is 25. So remember, we have the sum divided by the number of data values equals our average, which in this case, our mean, is 25. So now let's think, oh, do we have the number of data values? Yes, we do. The number of data values is 4. So what number divided by 4 is going to give you 25? You could work backwards, do the inverse operation, multiply by 4. You're going to end up getting 100. 100 divided by 4 gives you 25. So that means all of these ages need to add up to 100. Well, we have 12, we have 38, we have 41. What do we have so far? If you add up the 12, the 38, and the 41, so far we have 91, which means I need to figure out what must Jorge's sister's age be if altogether they're going to add up to 100. So I'm going to take my 100, subtract out the 91, and it looks like 9 is the missing age. Jorge's sister, let's do a different color. Jorge's sister must be 9 years old, because 12 plus 38 plus 41 plus 9 gives you that sum of 100, and we know that 100 divided by the 4 ages is going to give us our mean of 25. Okay, last one on page 330. The fuel economy of Joe's car is 32 miles per gallon, and that's on the highway, and 26 miles per gallon in the city. That's very typical. You typically can get more miles in per gallon of gasoline when you're driving on a highway because you're not stopping and going. For the 2 trips shown in the chart at the right, combined, did Joe drive more often on the highway or more often in the city? Give a reason to support your answer. So this one's a little different. Here we are using the unit rate of 32 miles per gallon on the highway, 26 miles per gallon in the city, to figure out, did Joe drive more on the highway? Did Joe drive more in the city? I'm not sure. So what I'm going to do is I'm going to see, let's see, it looks like my totals here. Total miles driven, 420 plus the 190. That means I have a total of 610 miles traveled here. And if I add up the fuel used in gallons, let's see, 14 plus 6, that's 20 gallons of gasoline. So 610 miles total on 20 gallons of gasoline. So what I might do is I might find the unit rate here. I'm going to divide. When you're trying to find unit rate, all you have to do is divide the miles per by the gallons. So 610 divided by 20 is going to give you 30.5 miles per gallon. Okay, so my average miles per gallon, my mean miles per gallon, is about 30.5 miles per gallon, and that, I'm thinking 30.5 is closer to the 32 than it is to the 26. So I bet that Joe drove more on the highway than they did in the city, just because it looks like they are closer to they more likely got 32 more miles per gallon than they did the 26 miles per gallon. So let's see. Joe drove 610 miles using 20 gallons of gas. The average fuel economy was 30.5 miles per gallon. erase this a little bit. Okay, so the average fuel economy was 30.5 miles per gallon, and this is closer to the 32 miles per gallon Joe gets on the highway. Sorry about all this chicken scratch here. So Joe probably drove more often on the highway. Whew, that's a lot. Okay, so here are your takeaways. And what I focused on was when you're trying to find the missing data value when you have the mean. So this is just like number 5 and number 6. What you want to do is you want to make sure that you set it up like this. You have to think to yourself, okay, I've got all of these data values so far, and you might need to add more spaces. You know, it depends on how many data values they're talking about. And you have to think about what your sum might be. And in order to figure out what that sum should be, you want to use this setup. Think, okay, if my mean is 100 and the number of data values is 4, like it was in number 6, okay, what number divided by 4 gives me 100? That's the sum that you need to put in here. Or what if your data values are, let's say, maybe 8, and maybe the mean is 6? So you might have to think to yourself, okay, what must the sum be in this case? So I know 8 times 6 is 48, so this must be 48 over here. You have to be able to work backwards. You have to figure out what number divided by the number of data values gives you the mean that has been given to you in the problem.